Hi, I'm DJ Ware. On this episode of the Cyber Gizmo, there hasn't been enough videos done on VPN, so I think I need to add mine to the pile of videos on VPNs as well, just to make sure that we've covered every single base of it. So I'm going to talk about how it works and then how to block one, at least in broad strokes. And basically, I'm going to explain how other people have used blocking mechanisms to shut them down right after this. I wanted to kind of do this one because I got a couple of comments from some very knowledgeable users that listen, or I should say subscribers that listen to my channel. They certainly aren't users, but that talked about how Apple could circumvent anything that I could do by just simply putting the telemetry inside of a VPN. Yeah, they could do that, and I could still block it because it's exiting onto my network, and there's a firewall at the end that has a deep packet inspection filter installed on it. So I could they could do that, and I'll just try to block it the best I can, and we'll talk about that. So virtual private networks, let's start with the first problem. What is it? So a virtual private network is basically a private network that's encapsulated inside of a public one. So basically, I'm creating a tunnel through the internet to communicate between two sites or two users. And that ensures that communication that occurs is private by encrypting it. It encrypts the message, the traffic, so that somebody that's on the outside looking at it is just going to see nonsense going back and forth over the network. There are two types of VPNs, two broad categories. There's the remote access VPN, which is probably the one that you'll probably be encountering most often. And that allows users to establish secure network communications with a remote computer network or a remote server. Businesses use them to permit corporate LAN access to employees who are traveling, or maybe they're at home, human malware. And they're confined there, so they need access to the corporate LAN in order to continue to do their work. Businesses can use VPNs to connect remote offices as well. So in the old days, you had to install lease-line or X.25 packet networks in order to consolidate that traffic together to allow communications to occur, and that got expensive between remote offices and a corporate LAN. That got real expensive because you have tariffs that are involved, and the longer the distance is, the more tariffs you get to pay. So those got to be very expensive, and so VPNs have helped reduce the cost for that kind of access. There's also site-to-site VPNs. Typically, you find this when corporate LANs need to be able to bring in more than one remote office. So they may have many offices that are around the world, and they need them all to come back into the corporate network. So a site-to-site VPN is exactly what does that. There's some other things that a site VPN can do. The typical use is over an intranet is what they usually call it. And that is a single network that connects all of those remote offices and corporate LANs together. So they can basically talk to each other. There's also one that's used over what's called an extranet. Now, you don't hear extranet used all that much anymore in terminology, but generally that is for B2B or business-to-business relationships. Like I have maybe it's a customer that needs access to, maybe I'm creating a product, and they want access to the status of the order, or maybe they need support, or any number of things can occur there for customer access. There's also ones that are used for other businesses. Maybe I have a business partner that is supplying some kind of material or part that's used in the construction of whatever I'm building or doing. And so they need a limited environment in order to share information, but there are ways to restrict access so they don't get access to the private internal network. So I'm not going to take the protocol apart and go through, at this step, this packet gets sent and then this ACK comes back. I think if I did that, I know I would fall asleep. I'm sure you would as well. So let's just talk about it in kind of broad steps about what happens. So in step one, I need to get authenticated to the VPN server so that it says, oh, you can establish a VPN connection to me, you're fine. or no, go away. I don't know who you are. So it can't, a VPN doesn't really know that you're an individual. It doesn't know who you are. Although there are ways, I suppose, they could use the payment method to track who you are. But there are some VPNs that they allow payment through anonymous sources like, pay cards and that kind of stuff. But basically, it's a key exchange. I send a key, they get it, they validate it, and they say, okay, good. Here's my key. We're all good. We're all set to go. So that then establishes the first part of the communication. The second part, now I have to determine what protocol to use. And that is usually defined in a configuration file, and it usually is specified by the server side. But that is then checked to make sure that it's correct and everything looks good. And so there are many protocols, of course, to use, as all standards, there's so many to choose from, right? That you can use in typical VPN exchanges, one of which is IPsec. That was developed by the IETF for IPv6, and you can get an implementation of IPsec for IPv4, but there's already a variant of it called Layer 2 Tunneling Protocol, or L2TP. There's several versions of that. There's version 1, 2, and 3. There might even be a 4 now. I'm not sure, but I know there's 1, 2, and 3 that is used. There's also the Transport Layer Security, which is basically SSL, TLS handshakes. OpenVPN uses that one. There's also Datagram Transport Layer Security. That one was developed by Cisco for their product AnyConnect. I don't believe that is currently supported. And there is a OpenConnect VPN service that uses that same protocol as well. And Microsoft, of course, has their own version of Secure Tunneling Protocol, which is basically their idea of how to do SSS TLS. And then there's older protocols like Point-to-Point Protocol and Point-to-Point Tunneling Protocol. Don't use those. I mean, obviously, PPP doesn't encrypt, and PPTP, the encryption on it is so old that anybody with even a half-decent computer today could unencrypt that message pretty quickly. So don't use those. Those are not good ones to use. There's also, of course, the Secure Shell Protocol, VPN. OpenSSH offers a VPN tunnel that will then secure remote locations, and it has the advantage of offering personal authentication. So as you log in, of course, as you negotiate and you log in, so you have that extra thing that VPN cannot do. WireGuard is pretty new. It was just added recently to Linux this year and Android as well. That uses Curve 519 as the mechanism for key exchange. Don't confuse that with elliptic curve. They are not the same things. And there's also, it uses CHA-CHA20 for encryption of the data packet itself. So yeah, WireGuard is new, and it's also a part of the VPN protocol stack now. VPN 3, VPN encapsulates, then at that point, once it's got the protocol it's going to use, then it will take whatever the packet is you're trying to send. Maybe it's a request to a website. It'll take that packet, and then it'll use the private key or the symmetrical key, and we'll talk about that. It encrypts it, and then puts a VPN packet around it. So it encapsulates your packet inside of the VPN packet. And then it sends that to the endpoint. It is client server, but they are actually just endpoints because they both can initiate and communication one to the other. So it isn't like I have to send them a request and then wait for a response back. It isn't a typical client server application. So that's basically it. It wraps the packet and then it sends it encrypted up the other end. Once the endpoint receives that packet, it then it takes it out of the wrapper, it unencrypts the data packet, and then it makes itself the source IP address. So its IP address becomes the source IP address on the packet, and they fire it to whoever is in your destination ID, and then that place does it whatever it's going to do, and it sends a response back, and then the reverse happens. That the endpoint takes that response, encrypts it, encapsulates it, sends it to you, and then you unpack it, you unencrypt it, get your message, and then rinse and repeat until the VPN session is over. Does that sound simple? It isn't all that complicated, really. It's just basically you're encrypting everything and you're making sure that none of the header and the original packet is available for anyone to see. So there's also another piece that is offered by some VPN providers called Split Tunnel. And Split Tunnel allows the VPN software to be configured to include applications that you may not want to pass over the VPN. For example, Netflix will block VPNs. And so you might, for the Netflix app, you may say, oh, I want this to go across the network unencrypted, so just use my normal internet connection for that. And that's what it does. Otherwise, you would have to go up and shut down your VPN while you're watching a Netflix. So this was really enabled to allow those VPN traffic signals to continue while allowing others not to use that mechanism. So there's also the encryption types, the keys that are used and deployed in VPNs. And it's the same two that are always around. There's a symmetrical key encryption. That's a shared key. So the same key is used for encrypting the message as decrypting the message. And all the users that are using that particular VPN service and connection all share the same key. The public key encryption is a traditional public-private key. So in this case, the private key is used to encrypt and then the public key is used to unencrypt. But since both ends can do that, they each have their own public and private key pair. So you actually are dealing with 4 keys here, 2 private keys, 2 public keys, 1 for each end. So, and then they use the respective public key to unencrypt the message that's coming down. So that's it. That's basically it. So which VPN protocol is the best? And I know somebody's going to ask this, so I might as well answer it. Well, we already said PPP and PPTP, don't use those. LTF I didn't really mention because the layer 2 forwarding protocol is actually part of the authentication scheme that's used in VPN, and that was developed by Cisco. L2TP, that combines PPTP and L2F. Wait, you just said not to use PPTP. Well, it has been enhanced. There's a couple of versions. There's version 1, 2, and 3. And so it fully supports IPsec. However, Snowden says don't use it because the NSA has weakened it. So I can't put it in my recommendation. If that had come from anybody else, I would have said, oh, well, I don't believe it. But because it came from Snowden, I do believe it. So there's another one, transport layer. We talked about that. That works good if your network has a NAT firewall, meaning that there's a IP address that's used to communicate to the outside, and there's a firewall, and then it in turn gives you a different IP address that would be non-routable. That's usually associated with a NAT. And some VPNs have problems with NATs, but if you're using the TLS protocol, that will get around that. It'll work pretty good. Not all of these protocols work well with NAT. There's also the datagram transport security, layer security. That's not a good one if you're using SSL, simply because it has to put a packet inside of a packet. So now you got 2 things you have to unencrypt. It adds huge delays, and whenever you have huge delays, TCP/IP being best effort could say, forget it, I'm dropping the connection. That's not a good thing to have happen in a VPN, and we'll talk about that at the end. So, IPsec, yeah, you can use it. You might find it a little bit rigorous to set up. It takes a while to do it. Now, if you do it every day, I'm sure it's real easy for you. I mean, I'm sure I'm going to have somebody go, well, I use IPsec at work. It's fine. It's yeah, but the first time you encounter it, it's going to be, oh my God, this is crazy. All this stuff I got to do. So, home users typically don't use IPsec, but if you really want to, you can. Just make sure you test it thoroughly, because there's a lot of ways where you can pop data out of it without knowing that you actually exposed it. And of course, there's Microsoft's version of TLS. And of course, if you're using Microsoft products, to talk to Microsoft products, you're probably stuck with it. So you don't have a choice. SSH VPN, it's a good one if you need personal authentication. And it's nice. And VPN, of course, doesn't have an equivalent to that. WireGuard, it looks good. I mean, I know they passed some of their verification or the security verifications, but I really think it's kind of early. It was kind of the first phase. I mean, whenever you hear people go, oh, we passed the security verification, and then you go, what step? And they go, oh, step 2. Oh, well, you got a ways to go then. Yeah, they haven't completed all the steps. The problem is that a lot of those steps require real world tests. So, yeah, get out there and test it and add to the pool of knowledge, but put it in production? I wouldn't. I mean, I'm not telling you what to do, but I wouldn't do it. Not yet. Maybe a little bit. It's very simple protocol. Let's put it that way. It's very simple. And that can be good and bad. But you talked about VPNs being blocked. How does that work? So before we talk about that, let's talk about the fail-safe here. So in the case that your VPN disconnects for whatever reason, maybe the VPN server goes down or whatever, or maybe the connection times out, maybe you just get swamped with traffic and the thing goes down. So your traffic normally would just spill out over the public internet with no encryption over top of it, and you're going to go, oops. If you weren't watching there's a little green dot that usually says it's connected, and then it goes red when it's not. So now in Linux, if you're inside of a command line, you don't see that. So if you're not watching that, you could be spilling traffic over the internet unencrypted, at least not encrypted additionally over the VPN. So a lot of VPNs include something called a cutoff switch, and that means that if the VPN were to shut down for some reason, it will just kill the connection to the internet. Period. Over that Ethernet connection will just die, and nothing will come in or go out. So that's a nice thing to have, unless you're going to be diligent about watching what's going on. So what about blocking it? So let's talk about the Great Firewall of China. They use it. I mean, I know of some things that have been announced publicly. I don't know all of the mechanisms they use, but I do know that these two have been mentioned publicly. So there's a number of mechanisms they use to block open VPNs, or any VPN for that matter. First is they look for known ports that the VPN uses to authenticate on. The second way is they have deep packet inspection in order to determine behaviors of that protocol. So they might see a TLS exchange. They might see a lot of traffic coming over the same IP connection going to different hosts all at once, and they're going, wait, what? How's that? What's going on here? They might identify fingerprints in the data traffic, like it's peaking and it's all going outbound, and they're going, what are they talking to? And there's ways that they can determine that and shut it down. There's also artificial intelligence is also entering into this realm as well to identify VPN packets as well. I keep saying OpenVPN, but they're just one out of many. Netflix does block VPN traffic, and that was because of abuse by, I'm not sure the exact case, but it was one country that was using VPNs to look like a U.S.-based connection so that they could get access to Netflix, whereas in their home country, Netflix hadn't set up any kind of access yet. Usually it has to do with payment, and they just haven't set it up yet, and so they were circumventing it using VPN as well. Netflix said no, because it was more than just them. You know how abuse works, right? So my buddy gets the key, and everybody gets the key, and we all use it, and it's all free, right? They caught on to that pretty quick. There's other methods to look for abnormal number of connections coming from the same IP address. I mentioned that one already. And Wikipedia blocks looking for open proxies that are used by VPNs. So if they see the connection coming through one of the known open proxies, they just, no, you can't edit. You can read it, you just can't edit the page. Now, if it's coming from a closed proxy, they won't know that, right? So, but there are some ways that they can do that. So I guess probably next time I'll dig into Tor a little bit. If you guys like this kind of thing, I'll dig into Tor next, and I'll add my video to that pile as well. There just isn't enough videos on VPN, so yeah, I'll and Tor. So yeah, I'll add mine in there as well, and we'll talk about that one. So let me yeah. So next time, I don't know what I'm waiting on. Mageia, they're a Mandrake distro, and they're about to drop version 8. Although I think they've run into some issues that they have to fix before they can release the distro. But it should have been out by now, and it's not. But that's fine. Fix the bugs. This isn't a beat on them and say, well, you missed your date. These people work on this stuff on their free time, so it's kind of hard to you didn't release this when you said you were going to. That's not how you should approach this. It's just fine. Take your time, get it working right. Well, I would prefer to have it come out and run than have it come out with bugs in it. So anyway, hope to see you all again real soon, and hope you enjoy the video. Please like and subscribe. Talk to you soon. Bye-bye now.